People tracking using the FLiR camera. This project involved the design and prototyping of a thermal camera positioning system, a complex integrated system of machine vision and mathematics to position a human onto a two-dimensional bird's-eye view map. The team was given two main components to create this product. The first one was a Raspberry Pi. The Pi is a small, portable computer used for image capturing and processing through the use of the OpenCV library as well as the FLiR camera SDK. The second component is the FLiR Lepton long-wave infrared camera. The FLiR is a camera module that captures infrared radiation as an input through a sensor and outputs a thermal image. The primary route taken to accomplish this product was to separate team members into groups to work on various components in which they had strengths. Chris worked on the SPI interfacing and the software build system. Ghaith and Trung worked on detecting the human and tracking them using machine vision algorithms. Hayden worked on the coordinate extraction system using various mathematical concepts. Tuan and Kosta worked on the database, user interface, and rotation of the coordinates to suit the test environment. And finally, Jonathan worked on the architecture modeling, use cases, and alternative components research. Development of the product was broken down into two main sections: detecting and tracking the person, and then extracting and mapping their coordinate location to a two-dimensional bird's-eye view floor plan. The first step in the development process was to capture a frame using the thermal camera and detect the human figure. To do this, various types of background subtraction algorithms were used to isolate the foreground subjects from the non-moving objects such as light fittings. Mathematical operations on the image via the inbuilt OpenCV algorithms were used to decrease the noise. Blurring was used to fill the gaps in the human figure to make it more visible to track. Secondly, isolation and head detection algorithms were built by the team to obtain the necessary data to be sent to the mapping module. The points in the contour that are around the head are filtered and tracked. Finally, as a sanity check, color isolation was used to confirm the head was detected correctly. The width and height of the bounding box surrounding the head is then passed to the mapping module. The functional requirement of coordinate extraction was to extract an overhead x and y coordinate of an object, in this case a human, from an image of a 3D space. A camera lens distorts the image in a curved relation to the center of the camera field of view. Therefore, curved equations were used to work out the coordinate of a person in the room if the camera is positioned at a horizontal view in respect to the ground. To find the z coordinate, which is the imaginary depth plane or the distance that the object is from the camera, the width of the person's head was used. The width was inserted into a quartic equation at the appropriate interval, which was determined via data collection. To find the x-coordinate of the person in the room, a scaling equation was used. At the intervals that were used to find the distance, the width of the image in pixels was compared to the width of the actual screen coverage in meters. Therefore, using the width of the head once again, the algorithm was able to determine how far left or right the person is in meters from the center of the frame. Displayed on the screen is our fully functional integrated system. Firstly, to the left you can see one of our team members walking around the room. In the middle, you can see our various algorithms collecting data and extracting the coordinates of the person from each frame. And on the right, you see the user interface, named eWare, in which the person is displayed as a red dot, from a bird's eye perspective of the environment. People tracking and mapping have a vast range of applications. In this case, it was specific to an aged care facility to ensure safety and security for the elderly. The team used Trello and Google Drive to manage our task allocation and documentation, and code was managed in GitHub. We did have some challenges right from the start, with hardware options such as camera angle and processing power, but in all, we were able to meet the brief and complete a fully integrated piece of software.